This question is taken from summer 2002. It states as two similar coils A and B of insulated wire are wound onto a soft iron core as illustrated in the figure. So we can see here this is a primary coil A and the secondary coil B, which is connected to a source of voltage. So as the switch is on, the current flows in the circuit. So when the current I in the coil A is switched on and then off, the variation with the time t of the current is shown in the figure 6.2, which is this one. Now figure 6.3 shows the variation E and T. So the question states that we have to draw a graph to show the variation with time t of the EMF E induced in the coil B. So actually we have to relate the EMF with the induced EMF with the current. So as current varies, induced EMF varies. So what's the basic principle for the induced EMF is negative d phi by dt, where this is the induced EMF I'll just write it as EMF and phi is the flux. So rate of change in flux is equal to this induced EMF with a negative sign. So the flux through a coil can be given by this formula: mu naught n times L times the I. So mu n and L are the constant, so we can write EMF as negative mu naught n L di by dt. So with the passage of the time only the current changes, so that's why we can write it. So from here we can see that the EMF induced depends on two things: the gradient of the current variation, and the other thing which we want to show is the negative sign, that it will have an opposite sign as that of the current value, like the gradient value of the current. So we divide our graph into 5 regions: 1, 2, 3, 4 and 5. So for region 1, 3 and 5, we have a straight horizontal line whether the current is 0 or maximum, but if it is not varying, its gradient will be 0. For the region 2, we have a positive gradient, but it's decreasing. For the region 4, we have a constant but negative gradient. So we show these 5 regions on our EMF graph, which is 1, 2, 3, 4 and 5. The region 1, 3 and 5 have the 0 gradient, that's why 0 EMF induced. In the region 2 we have a decreasing gradient, so it means the EMF induced must also decrease, but as the gradient has a positive value, so the EMF induced has a negative value, so its negative value will decrease, like from -5, 4, 3, 2, 1 to 0, so like this. And for the region 4 it has a constant gradient, so within this region its value will be positive because the gradient is negative, so negative and negative makes it positive, so the EMF induced is positive. So that's what we have the shape of the graph.